listeners, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe, share my videos to your friends and to your friends' friends. That's the only way you can help promote my channel and to keep me going and refreshed. So here is an example of energy method, deflection methods to frames. Determine the vertical displacement at sea by virtual work method and horizontal displacement at sea by Castigliano's second theorem. Take E 200 gigapascals. The moment of inertia with segment is shown in the figure. So let's section the frame element. There are two as shown in the figure. So by virtual work method, let's apply a unit virtual load of 1 upward at sea. Let's assume that the deflection is positive always. And that's the sectioning, and for this section here. So we will denote the moment of inertia of BC, this one as I. Therefore, the moment of inertia of AB is 4 times I. So this horizontal distance or the moment arm of the unit virtual load is x sine of 45 degrees. So this is x sine 45 degrees. And that's also x. While this distance is 2 sine of 45. EI delta C vertical equals integral from 0 to 2. The moment in this section due to the load is negative 50 because the positive sense should be counterclockwise if we consider forces to the right of the section. Then the moment due to the unit virtual load is positive 1 times x sine 45 degrees. Then since the moment of inertia is 1, so we just leave it divided by 1. At this section, the moment is still negative 50 from 0 to 3. Then due to virtual load, 1 times 2 sine 45, this is 2 sine 45, then plus x. Then whole integrand divided by 4 because the moment of inertia of AB is 4 of the moment of inertia of BC. So integrating using your calculator, this is negative 70.7107 and this one is negative 109.283. Combining, delta CV is negative 179.994 over EI, where EI is 200 times 10 to the 6 kilopascals times 100 times 10 to the 6 mm to the 4th divided by 1000 to the 4th. So that would be 20,000 kilonewton meter square. So the calculation is not shown, but because of our experience, you can verify that. So shortcut, so that the answer will be in mm, we divide just this expression by 20 and it is now in mm. So delta C vertical equals negative 179.994 over 20. So that would be in mm. So it is negative 9.00 mm or 9.000 mm downward. For horizontal displacement by Castigliano's theorem, so we apply a rightward force P to expect that to assume that the displacement is always in the positive direction. So this is x cosine 45. Remember this distance earlier, the horizontal projection of BC is 2 sine 45. It's not shown here, but I just explained. So at this section here, the moment is negative p times x cosine 45, then negative 50 integral. So this is 2 cosine 45. So EI delta c horizontal equals integral 0 to 2 of negative p times x cosine 45, then negative 50. The partial derivative of this moment equation is negative x cosine 45 dx over 1, because moment of inertia is 1. Then plus in this section here, 0 to 3 integral of negative p times 2 cosine 45 minus 50, then derivative is negative 2 cosine 45 degrees divided by 4 dx. Prior to integration, we set p 0. So the result of the integral for the first term is 70.7107. The second integral is positive 53.033. Combining, so delta CH is 123.744 over EI, and EI is 20,000, but let's just divide it by 20 to convert that automatically to millimeters. So delta CH is 123.744 over 20. So it is equal to 6.187 mm rightward.